Hello everyone. In this tutorial, we will be training a machine learning model that can tell an SMS is spam or not. So at first, I am opening Jupyter Notebook. I have downloaded a database from Kaggle called spam.csv. So it is a CSV file. I am copying its path and opening a new notebook here. To load the CSV file, I am importing pandas as PD. Storing the dataset into um, text, which is B, and I'm putting the path here. So it is showing that there is no directory for this. Okay, removing the previous part and shows the including UTF-8. Generally, this error don't come, but today showing. So I'm setting the encoding into UTF. I think this error is meaningless. We don't worry about this error. I am ignoring the error. Now let's check uh, what is inside this dataset. So there are 5 columns. View 1 shows the remarks that this SMS is spam or not. Second column shows the text. The text is not fully visible. Let me fix this. Pandas dot set option display dot max call with false. So there should not be any limit now. Okay. The unnamed 2, 3 and 4 all shows null values. So let me check how many null values they have. Unnamed 2 dot is null dot sum. It shows the total null values in column unnamed 2 is 5522. Now let me check the total dimension, the shape of this dataset. It shows there are 5572 rows, and among them 5522 are null values. So let me check the percentage of these null values into 100. So 99.1% values are missing in unnamed 2. So I can uh, drop this column, as doesn't this column doesn't contain um, any significant values that may uh, help us to train this model. Now let me check for unnamed 3. Same case here, around 98%. Column unnamed 4, same here. So I can drop unnamed 2, 3 and 4. as maximum values of them are now. Here I am passing all the column names. Okay. Oh, I need to uh, set in place true as this change is permanent. Okay. Now let's check text.head. As we can see, this text need this text should this text need to be processed. There are capital letters. Also there are punctuations. Also there are some uh, there may be some HTML links or not. I don't know. So I am applying all the preprocessing techniques here. If there are some uh, links or links, URLs or HTML codes, they need to be removed. So I am applying preprocessing to remove HTML tags, punctuations, URL, and finally lowercase. To remove the HTML tags, uh, to remove HTML tags and URLs, we need a library called real expression. Also for punctuations, there are a lot of punctuations. We can't write them all manually. So we need a library. So I'm importing Spring. So why Spring? Because inside Spring, uh, Spring.punctuations, it has all the punctuations as a list. So we can't write all of them manually. Even if we can, it's too much uh, risky. So I am listing them to exclude, exclude variable. Okay. So this exclude contains all the uh, punctuation marks. So I'm defining a preprocessing function, and later we can call this function anytime, and it will do all the preprocessing tasks for us. Preprocessing. It will take the text and first of all I am removing the HTML text. Pattern contains the real expression dot compile, and this inside compile I am writing some codes that can be available in Google, or you can memorize this if you can. Uh, this is a magic code actually. Then what we will do is remove this pattern from text. So I am storing inside text pattern dot remove uh, dot substitute. Going to substitute with space. That means if we find any HTML tag inside text, it will remove, it will substitute the HTML tag with this space. Now, removing URL. This Jupyter notebook is too much annoying. URL. Same thing here. Just change this here. There should be an R. You can find this pattern online. No need to remember, but you can manage. Okay, done with URL. Now, for punctuation, we save the all the punctuations in explode. So we need to uh, replace or substitute these punctuations mm, with space. So you can run a loop for uh, punctuation in inside explode text equal to text dot replace too much anyway. Uh, Punctuation, we will replace the punctuation with space. Space means nothing. Okay, punctuation. Now the remaining is lower. Now we will lower casing of the text dot lower. Now return the modified text. Okay, we're done with this preprocess function. Now all we need to do is to call this function to fix the v2 column. So the text and accessing v2 and applying this function to v2, apply preprocess. So what were we doing here? I am applying the preprocess function uh, to the v2 column of our data set and storing the modified v2 column into the original v2 column. I mean, I'm replacing the fixed one with the previous one. So enter. Now let's check again. Text.head. So there is no punctuation marks, and all the letters are lowercase. Now, uh, now, as we know, that computer can only process the uh, numbers, digits. It can't interpret these uh, letters or words. So we need to convert these letters into numbers. So for V1 there are the levels. Uh, for them we can use level encoder. What level encoder does? It replaces spams with 0 or 1, and if spam is replaced with 1, then ham is replaced with 0. Okay, so there is only 0 and 1, 0 indicating ham and 1 indicating spam. Or it can also happen that spam is indicated by 0, indicated by 1, and ham can be indicated by 1, indicated by 0. Okay, so I'm doing level encoding. For level encoding, there is a library called scikit-learn from scikit-learn dot encoding preprocessing import level encoder. I'm creating an object of level encoder. L. Okay, calling this L. Now what we need to do is to input this v1. So text v1 equal to L dot fit transform text v1. Let's run this, and yes, I think it's done. Now let's check. Okay, check it again. As I said, the spam is indicated by 1 and ham is indicated by 0. Okay, now done with this v1. Now it's time to uh, numberize this v2. So for text we have a library. For text we have a library called count factorizer. For this we will import from uh, scikit-learn dot feature extraction dot text. Import counter factorizer. As previous, I'm going to make an object of this counter factorizer, count factorizer, and I'm leaving on this as it is. Now as previous, selecting here v2 and pv dot fit transform. Wait, this count factorizer uh, does two things. First of all, it breaks the sentences into some words, into valuable some valuable words, or this is called token, that tokenizes, that will uh, convert go until jorung into go, comma until, comma jorung, and all this, and then it will map these words with a digit or number. So it actually creates a dictionary. So uh, we 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 want to directly feed all the text this into this dictionary. Rather, first, rather instead of this, we will uh, split the dataset into two parts. One is test, one for training. So for this, I am importing a library from sklearn dot preprocessing, no, model selection, import train test split. Okay, x train, comma x test, comma y train, comma y test equal to train test split. Here x will be text v2 and y will be text v1, comma shuffle to random state. I am giving random state 42. This can be any number. It actually uh, remembers the random state. I mean, I am as it will shuffle all the rows. So for a fifth random state number, the shuffle is always universal, and there is remaining trend uh, test size. Test size equal to I am setting test size 15% or 0.15. Okay. Now, now I am now going to uh, apply the feed transform to X train and Y train, and setting them to um, where will we set this? Okay. There's no Y train, only X train. So what will it do? It will find a dictionary for these words uh, inside X-ray. mm, X-ray. So I'm naming this X-ray map, and it will apply the dictionary to X-test map. So for test, I am not fitting. I am rather than only transforming. The dictionary is extracted using xtrain and applied the dictionary to both xtrain and xtest. Okay, now we will further work on xtrain map and xtest map. Let me check the xtrain map. How does it look like? Also, it's showing uh, sparse matrix. That means we need to convert it into list dot to list. Okay, so it should not be list. It should be array to array. Okay, dot to array. Now we can view this aspirant map. What's the problem with this? Yes, yeah. So they have also this what this is converted into a list of numbers, an array of numbers. Now, as this all of them have converted into numbers, now we can start our training process. So for training, we will try different models. So first of all, I'm trying naive Bayes uh, model for training. Scikit-learn dot naive Bayes import. There are three types of naive Bayes. One is Gaussian naive Bayes, one is Bernoulli naive Bayes, and multinomial naive Bayes. Also, uh, we we can apply another model like linear regression. Generally, these models do results in better results or better score. So I'm using them. So for mm, uh, Gaussian model, I'm creating an instance. Same for Bernoulli, BNB, Bernoulli neighbors, and MNB for multinomial neighbors. For linear regression, I'm taking LR. Also, there are some hyperparameters, but I am taking all this by default, not changing anything. So at first, I'm fitting with Gaussian model, fit x train left, y train left. No, y train is y train. Actually, y train is not defined. I think no, it was defined. Okay, so I'm fitting this, but it's showing error. Oh, it should be explained, not test. Yes, it is trained. We can see it is fitted, and yes, it's fitted. Now fitting all other models too. GNB, then comes BNB, also there comes MNB, LR. So all three models are fitted, and linear regression model is being fitting. So let me check their accuracy. For this, we need a library dot matrix import. We will import confusion matrix. Confusion matrix and accuracy score. No, we don't. We no need of confusion matrix. We will just use accuracy score for now, um, and the accuracy score, it takes two parameters. One is y real and uh, y actual and y predicted. So the actual one is y test, and the predicted one is GNB dot for Gaussian model, GNB dot predict x test map. So it is giving 88% accuracy. So I'm writing here print for Gaussian knife bias. Now for I'm also writing for others too. GNB, then comes BNB, Bernoulli knife bias, and multinomial naive Bayes and logistic regression model. This is for Bernoulli. This is for multinomial. This is for logistic regression. So it's I think this classification. So this uh, linear regression might not be applicable for this problem. It's showing error, so I'm deleting this. So as you can see, the multinomial naive Bayes gives a maximum accuracy, and it's 98.32%. That is good enough. So this model can uh, predict or classify this message with accuracy score 98%. That is quite good. So that's it.